Okay, these are going to be your lecture notes for this week. We're starting the periodic table, and I need to make sure that you have these lecture notes viewed and that you have your notes written before you come to class on Thursday. I'm going to start class on Thursday where this lecture note stops. So if you don't have notes on these things, you'll be completely lost and won't know where we are in this lesson. So I will put on Schoology that this lesson must be completed before lab on Thursday. All right, so what we're looking at is the periodic table. We're going to be looking at the trends that are on the periodic table. The periodic table is organized based on how the elements behave chemically with each other, and it's also based on what each of the elements weigh. Some other characteristics of the periodic table is that the elements are arranged in order of increasing atomic number, and we know that atomic number is based on the number of protons that are in an element. And the elements with similar properties appear on the same periods, which is the rows that go across are called the periods, and then they also fall within the same groups, which are the columns that go up and down. So looking at a periodic table, we have these that come across here that are called the periods. The periods are the horizontal rows, and that there's 7 periods that go down. And when you look, there's 2 elements in the first period. There's 1, 2, 3, 4, 5, 6, 7, 8 elements in the second and the third period. And there are 18 elements in the 4th, 5th, 6th, and 7th period. Okay? We'll go more into it on how that actually works, but you need to know that this way the horizontal lines are called the periods. And then you have these ones that go up and down here, and these are called the groups. All right? When we're looking at groups, they refer to, they're actually organized by the number of valence electrons that are in the element. And we learned that a valence electron are the electrons that are in the outermost energy level of an element. So if we look at this one, group 1, all of these elements, hydrogen, lithium, sodium, potassium, all of these have 1 valence electron. And then this group 2, all of these elements here have 2 valence electrons because they're in group 2. Then group 3 goes all the way across this whole thing all the way to here. So even this row right here are group 3. And all of these elements carry 3 valence electrons. Then we have this one right here, which starts with carbon. Carbon has 4 valence electrons. This is group 4. Group 5, group 6 with oxygen, they have 6 valence electrons. Group 7, and then you have the last group, which have 8 valence electrons, meaning that they're stable. Their outer shell is completely full. Okay? We'll go a lot more into that. These ones are actually called the noble gases because they have 8 valence electrons and they're filled. That they have the most they can carry, which is called the octet rule. Octet meaning 8, and it has already in it 8 valence electrons. So looking a little bit closer on the periodic table and how it's organized, the first thing we're going to look at is the way the elements are grouped. And the first grouping we're going to look at is whether or not they're a metal, a non-metal, or a metalloid. And we looked at this a couple labs ago when we were talking about conductivity, and we did the test to find out if it was a metal or not metal. So looking at a picture on the periodic table, we have them grouped, and you can see a vast majority of them here are metals. So this whole side, and actually all of these down here, are metals. Hydrogen is actually most often is a non-metal. It's kind of annoying. It reacts differently in different situations. It can go in different categories. You'll have to make your best guess a lot of times with hydrogen, but for all sakes and purposes on a periodic table, hydrogen will be a nonmetal. Then you have all the metalloids here going down the middle. These all will be touching the stair step, and the metalloids can react either way, as a metal or a nonmetal. And then we have these ones over here, which are the yellow ones, the nonmetals. And when we were learning about those, we learned that they do not conduct electricity, they are brittle, they're not malleable, they won't bend. Yeah, they're not shiny, they don't have a good luster. So, first way of grouping the elements could be with metals or nonmetals. We're going to go back now and look at the periods and the rows, and we're going to look a little bit specifically at each of these groups of elements, and they all react similarly and they all have names. So let's look at group 1 elements. So we're looking at specifically lithium, sodium, potassium, group 1 here. These are called the alkali metals. They are all carrying 1 valence electron. These are highly reactive with water. We'll see a demonstration on that where we can see how reactive they are, meaning that when you put them in water, they're going to have a vigorous reaction. All of these metals are silvery in appearance. They have a good luster. And many of them are soft enough to be cut with a knife. And we'll see some of these in labs on Thursday. So group 1 is called the alkali metals. Right, let's go to group 2. Group 2, these are called the alkaline earth metals. Each of these elements have 2 valence electrons. So if you look here, we have the nucleus, we have the first energy level is filled with 2, and at the second energy level, they're only carrying 2. Which would make sense because beryllium is 4, meaning it would have 4 electrons. The first 2 are going to go in the first energy level, and the next 2 are going to go in the last energy level. So this has 2 valence electrons. It's harder and denser than the alkaline metals, but it's reactive as well. Not as reactive as the plain alkaline metals, but they'll still react when they're put in water or different chemical situations. So looking back up here at the periodic table that we started with, we have the alkaline metals and the earth alkaline metals. Then we have all these metals in the middle that are called the transitional metals. And that would be groups 3 through 12. These are called the transitional metals. All of these metals have 2 valence electrons as well. And then we're going to jump over to the one that's the farthest over. So let's look at our periodic table. So these are transitional metals. Then this is like the boron family, the carbon family, the nitrogen family, and the oxygen family. Each of these groups are called that. Boron, carbon, nitrogen, oxygen. Transitional metals, alkaline metals, earth alkaline metals. Then you come over here to group 7, and this is the group that's the most fun. These are called the halogens. So let's go to where the halogens are. They start with fluorine. These ones have 7 valence electrons, meaning that their outer shell is almost completely filled. And despite the similarities in chemical reactivity, some of these are solid, some of these are liquid, and some of these are gas. But these are the most reactive nonmetals on the periodic table. And we'll look a little bit more, but a lot of these like to react with other metals on the other side to make salt. So like if you're looking at this group over here, this is NaCl. So these ones like to get together. If you notice what they are, it's going to make salt. sodium chloride, NaCl. And this one has 1 valence electron, and this one has 7 valence electrons. So together they make 8, and that's why they want to go together, because every element's trying to make 8. And that's why those two, NaCl, work so well together to make salts. Okay. All right, I think let's just look at the last group, and then I'm going to stop, and then the rest of the lecture is going to be on Thursday. So let's look at the last group. We have the noble gases. These can be found in group 8, which is the last group, way over here. All right. And these are the noble gases. They're called the noble gases because they are filled. They have 8 valence electrons, so they have a complete octet. These ones are completely non-reactive. They're inert. They are unreactive chemically because they don't need to react with anybody. They've already have their valence electrons filled up with an 8. So they're called the noble gases. All right? So talking about valence electrons, we're talking about, again, and make sure you're clear on this, a valence electron is located in the outermost energy level shell. Okay? They're important because they are what dictate who this element is going to try to be attracted to, because they're trying to fill this outer shell to get to 8. Okay? When you're looking at this magnesium atom, you can see 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 in the second shell, so that's filled, and 2 left over. The reason why it adds up to 12 is because if you look at magnesium on a periodic table, it is right here, and it's 12. It has 12 protons, which means it has 12 electrons. And when you go to fill up its shells, its energy shells, you can put 2 in the first, 8 in the second, and then you have 2 left over to equal 12, and these are your valence electrons. If you have 2 valence electrons, you know that you're going to be able to find this element in group 2, because those are the ones with 2 valence electrons. And sure enough, when you look down here, group 2, there's magnesium, meaning it has 2 valence electrons. All right, this lecture is going to continue when you come to class on Thursday. We'll be talking a lot more about the periodic table and the electrons, but what you specifically need to know before you come to class is you need to know that the elements are divided into periods and groups. You need to know that the periods are the ones that go across this way, horizontal, and the groups are the ones that go up and down. The groups are based on how many valence electrons there are in the element. You also need to know what the name of each of the groups are, meaning I want you to know that group 1 is the alkali metals. Group 2 is the alkaline earth metals. Groups 3 through 12 are the transitional metals. And then you have the carbon family, the oxygen family, the nitrogen family, those families. You're going to jump all the way to group 7. Those are the halogens. And finally, the last group are the noble gases, group 8, or 18 on a periodic table many times, and those have 8 valence electrons. The last thing you need to know before you come to class on Thursday is that elements can be grouped into 3 types. We have metals, nonmetals, and metalloids. And when you look at them on a periodic table, they'll be arranged this way, with the metals here in blue. The metalloids will be on the stair step, starting with boron. And then the nonmetals are yellow, from carbon to the noble gases. Alright, please make sure you have a complete set of notes. I'll be checking this before you come to class on Thursday. If you do not have these notes, then you will not be able to stay for the lecture on Thursday. I look forward to seeing you guys in Miss Kanowski's lab on Thursday. Bye.